Hello students, myself Mahavir Singhvi. Again we are with new video on our Alchemy online class. So in the previous video we have learned about how to represent irrational number on number line. Okay, in the previous class we have learned all about root 2, root 3 and root 5. I have given you homework also. I think you have done it. Okay, so in next class now we will study about the real number and their decimal expansion. It is a main topic of our chapter, one of the main topic, real number and their decimal expansion, types of decimal expansion and representing real number on number line. Okay students, so today we will cover these three topics. So what is decimal? First of all, before study types of decimal expansion, we have to study what is decimal. Decimal is any number in our base 10 number system. As you know, decimal number is a number written after decimal point. Okay, and the position of the digit in the decimal number determine its digit value. It defines its face value. Decimal shows number that are in between two whole numbers. I am again reading this statement. Decimal shows number that are in between two whole numbers. Suppose a number, decimal number is 3.2. So it is in between 3 and 4. So 3 and 4 are whole numbers and 3.2 is a decimal number. Is it clear? Suppose it is 4.22. So 4.22 will be in between 4 and 5. So 4 and 5 are two whole numbers and 4.22 is a decimal number. Next, decimal has two parts. Decimal number, any decimal number will have two parts. An integer part and the fractional part. Two parts, integer part and a fractional part, which start with the dot character. Means we say decimal point. Look here, the example it is given 65.894. So before decimal point it is known as whole number, and after decimal point so it is integer part. Before decimal point number written is integer part and after decimal part it is fractional part. Is it clear? Next, now we will study about types of decimal expansion. There are two types of decimal expansion, terminating and non-terminating. Two types, terminating and non-terminating. In non-terminating there are two subparts, repeating and non-repeating. So non-terminating repeating and non-terminating non-repeating. So what is terminating decimal expansion? So first, terminating decimal expansion reaches an end after a finite number of digits. It will end after finite number of digits. Suppose 1.25. It is a decimal expansion, and 1.25 it is an terminating decimal expansion because after 1.25 it stops. Terminates means it ends. So this is known as terminating decimal expansion. Next, a repeating decimal means non-terminating. If we talk about non-terminating means which never ends. Its name only suggests non-terminating, which never ends. So non-terminating decimal expansion is that decimal that does not end, instead goes on forever. It will goes on forever. So 1.33333333, 2.5555, suppose this kind of numbers are non-terminating number. Okay, so in non-terminating, which is repeating is, suppose we divide 1 by 3, answer will be 0.333333. So it is repeating. The number is 3 digit 3 is repeating, keeps on going. And next, non-terminating non-repeating. So here I have given 2-3 examples. 7 by 8 when we divide 7 by 8, you can see answer will be 0.875. So 0.875. Here remainder is 0, means our solution is done. So here value is ends 0.875. So it terminates. So this is terminating decimal expansion. Next, 10 by 3. When I divide 10 by 3, the answer will be 3.3333. 33 last digit will keep on going. So it is non-terminating repeating decimal expansion. Again 1 by 7. When we divide 1 by 7, the answer will be 0.142857 and it will repeat after 0.142857. This will keep on going. Next, an example of non-terminating and non-repeating. Students, you all know about pi. The value of pi is not 3.414 or 22 by 7. It is not exact value. In previous class, whatever value you have studied, it is considered as approximate value of pi, 22 by 7 or either 3.14. Exact value of pi never ends. You can see 3.141592653589799323 and it will never repeat also. It will keep on going and it will never repeat. So this number pi is non-terminating and non-repeating. This is an example of non-terminating, non-repeating number. And now we will learn about representing of real number on number line. A new method to represent real number on number line. So students, now we will learn how to represent real numbers. Among those real numbers, how to represent the terminating numbers, terminating decimals number on number line. So this 3.325 is a terminating decimal number as it ends after few digits. So 3.325. 3.325 is in between 3 and 4. As you can see, we have drawn a number line 1, 0, 1, 2, 3, 4. So 3.325 is in between 3 and 4. So we will use here successive magnification method. So in between 3 and 4, there are more 10 parts. In between 3 and 4, there are 10 more parts. So we have magnified this in lines segment, or you can say line, in between 3 and 4. So it becomes 3.1, 3.2, 3.3, 3.4, 3.5 and up till 4. So there are 10 parts. Now we have done till 3.3 and 3.4. 3.3 and 3.4. So in between 3.3 and 3.4, what will come? 3.32. So again we need to magnify. We need to magnify in between 3.3 and 3.4. So when we will magnify, again there are 10 parts. So those 10 parts are marked as 3.31, 3.32, 3.33, 3.34, 3.35, 3.36 and up till 3.4. So here we are done with 3.32. So in between 3.32 and 3.33, what will come? 3.325. So again we need to magnify. So we will magnify 3.32 to 3.33. Again 10 parts. 3.321, 3.323, 2, 3.323, 3.2324, 3.325. This is our point which we need to represent on the number line. So this is our point 3.325, and this is how we can represent the terminating, or you can say real numbers on number line. And which method we have used, students? We have used successive magnification method. Again I am explaining in a short. 3.325 will come between 3.3 and 4. So we need to magnify in between 3 and 4. When we will magnify, there are 10 parts, so it will increase up to 1 decimal point. So 3.31, 3.32 and so on. Again 3.32, next decimal point. So we need to magnify 3.32 to 3.33. So there are 10 decimal point. 3.31, 3.32, 3.33 and so on. Again now our main number 3.325, which will come in between 3.32 and 3.33. So we need to magnify again, and here is our answer 3.325. So we have used successive magnification method to represent this number on number line. So students, today we have learned about type of decimal expansion, which were they? Terminating and non-terminating. In non-terminating there are two subparts, non-terminating repeating and non-terminating non-repeating. After that we have learned successive magnification method to represent the terminating real number or terminating decimal number on number line, and you need to practice at home, so you will learn it properly. And for further any practice and learning purpose, you can refer Diksha app by NCERT for textbook, extra marks online platform for practice questions, and keep checking Flint app for more updates from Alchemy School. Thank you students. We will meet in next video.